Former President Donald Trump is no stranger to bold pronouncements. However, his suggestion to alleviate California's chronic water shortages by tapping into Canada's water resources raised eyebrows across the continent. Trump, with characteristic simplicity, envisioned a very large faucet as the solution, a pipeline channeling billions of gallons of water from Canada's abundant snowmelt to the parched landscapes of California. He argued that this massive water transfer would not only quench California's thirst, but also mitigate the devastating wildfires that plague the state. Trump's proposal, while captivating in its audacity, was met with a wave of skepticism and outright dismissal from experts in water management, environmental science, and international law. Critics were quick to point out the myriad legal, environmental, and logistical hurdles such a project would face, not to mention the potential for political tensions between the two neighboring nations. The idea of simply turning on a faucet to solve California's complex water crisis struck many as a gross oversimplification of a multifaceted issue with far-reaching consequences. Despite the chorus of disapproval, Trump's proposal brought to the forefront the very real and pressing issue of water scarcity in the American West, a region grappling with drought, population growth, and the increasing demands of agriculture and industry. It also highlighted the need for innovative and sustainable solutions to ensure water security for future generations. One of the most formidable obstacles to Trump's faucet proposal lies in the intricate web of international agreements governing shared water resources between Canada and the United States. The cornerstone of this transboundary water management framework is the Boundary Waters Treaty of 1909. The treaty establishes the International Joint Commission, overseeing water resources along the US-Canada border. It enshrines equitable sharing, ensuring neither country can unilaterally alter shared waters. Beyond the legal and political complexities, Trump's proposed water diversion scheme raises serious environmental concerns. Environmental scientists and conservationists argue that such a massive transfer of water would have profound and potentially irreversible consequences for ecosystems along the entire length of the proposed pipeline route. The extraction of vast quantities of water from Canadian rivers and lakes could disrupt natural flow regimes, impacting fish populations, riparian habitats, and the delicate balance of aquatic ecosystems. The construction of a transnational pipeline would require extensive land disturbance, fragmenting wildlife corridors, and potentially harming sensitive species and habitats. The pipeline's route could traverse mountainous terrain, forests, and grasslands, posing significant engineering challenges and increasing the risk of environmental damage during construction and operation. Moreover, the introduction of water from a different region could alter water quality and introduce invasive species into California's ecosystems, further disrupting the delicate ecological balance. The potential for unintended consequences highlights the need for a comprehensive environmental impact assessment before undertaking any large-scale water infrastructure project. Such an assessment would need to consider the cumulative effects of water diversion on both the source and receiving ecosystems, as well as the potential for climate change impacts. Even setting aside the formidable legal and environmental hurdles, the sheer logistical challenges of constructing and operating a transnational water pipeline of the scale envisioned by Trump are staggering. Building a pipeline capable of transporting billions of gallons of water over thousands of miles, traversing diverse terrain, and crossing international borders would be an engineering feat of unprecedented complexity and cost. The pipeline would require a network of pumping stations to lift the water over mountains and maintain its flow over long distances. These pumping stations would consume vast amounts of energy, potentially increasing greenhouse gas emissions and contributing to climate change, the very problem exacerbating water scarcity in the first place. Moreover, the pipeline would need to be designed to withstand earthquakes, landslides, and other natural hazards common to the regions it would traverse. Maintaining the pipeline's integrity and preventing leaks over such a vast distance would be an ongoing challenge. Leaks or ruptures could have catastrophic consequences for surrounding ecosystems and communities, potentially contaminating water supplies and causing widespread damage. The financial costs of such an infrastructure project are difficult to estimate but would undoubtedly be astronomical, likely requiring significant public funding and potentially impacting taxpayers in both countries. Thank you for watching. Please like and subscribe if you enjoyed, and hope to see you in my future videos.